graphs. And so more than anything else, it's just understanding what's happening. Okay. As we look at this graph, how is it going to connect to some different things? You did this probably a little bit in Algebra 2. We're going to do it a little bit more in detail here, and we're going to do it a ton in calculus. So this is something we do a lot in calculus, where we have to identify important parts of the graph. So a good thing to know. All right. First thing I would say is I did a bad job of labeling this graph. This is a graph of f of x. When we get to calculus, they will always tell you the name of that graph, and it's very important that you identify what it is. Otherwise, you might get thrown off. Question A asks you to find f of 2. Show me with your fingers. What do you think f of 2 is going to be here? Yeah, they all glance around, see what everybody else has, but -5 is correct. What's inside? Normally it says f of what? What's normally inside those parentheses? An x. It's not an x here. It's the number 2. So that tells you that your x value is 2. So go to where your x value is 2. Go to your graph, and I'm saying the y value because it says f of x. F of x means what's the y value? The y value is -5. That's what we're going with there. All right, so a little bit different if you forgot. Letter B says, is f of 9 positive or negative? Give me a thumbs up if you think f of 9 is positive. Give me a thumbs down if f of 9 is negative. Thumbs up if it's positive. Thumbs down if it's negative. It's positive. It's positive. How can I tell? The arrow. The arrow is a straight line. We're going to assume that if it's giving me an arrow with a straight line, it's going to be a straight line forever. So it doesn't exactly show me, but I'm going to have to assume a little bit there that f of 9 is positive. In fact, I would probably tell you that f of 9 is 1 if I drew a better graph and it didn't look like it started going up a little bit. It's supposed to be flat. Okay, but yeah, f of 9 is positive. State the domain. When we think domain, what are we thinking? X values. So what X values did I use here? So when I do this thing, I always think about working from left to right. We always want to go from the smallest number to the biggest. So tell me now when I touch the graph for the first time. There. Right there at -5 is the left side of this graph. Okay. Tell me now when I stop touching this graph. When did I stop touching this graph? Never. There's an arrow. It goes on forever. I never stop touching the graph. So I go from -5 until when? Infinity. -5 till infinity. At -5, did I actually touch the graph? Did I have an x value at -5? Yeah, so I'm going to use a bracket. We are writing this in interval. I'm writing this all in the wrong spot, sorry. A bracket at -5. I actually touched the graph there. I used that x value. Did I actually touch the graph at infinity? No, it's infinity. I can't reach infinity. Always a parenthesis on infinity. All right. It's always going to be brackets when we talk about domain and range, except for infinity, or if I were to have an open circle. If I were to have an open circle at the top or bottom of my graph, then it wouldn't be there either. Okay. So from there until there. Then we're going to do range. Range means the y values. Tell me now when I reach the bottom of my graph. Now, so my lowest y value is right here at -5. I'm kind of like drawing a box around my graph. You don't actually have to write on your graph, but that's what we're doing numbers wise. -5. Tell me now when I reach the top of my graph. -5 all the way until 4. At -5, did I actually use that value? Bracket, because I used that y value, and at 4, I used that y value. It's a bracket, -5 to 4. Everybody good so far? Then we are talking about where's f of x positive. When something is positive, what does positive mean? Careful there. Not negative. I would agree with that. It's greater than 0. Not going up. Don't confuse those two. Those are the ones we always confuse. Positive means you're above the x-axis. You have a y value that is positive. That's what f of x is positive. Okay? Not positive slope, but just positive. So where is f of x positive? Right here at the beginning. Remember, f of x means y. As I start on this graph, right here at -5, is f of x positive? Yeah, because my y value is 3 right there. It's a positive number. So starting at -5, I am positive. Okay, tell me now when I stop being positive. So I'm starting here at -5. There. You guys were timid. And everybody was a little unsure from -5 until -1. All right. I kind of skipped over this, but that word where is doing a lot of work here. Okay. In a math class, when I ask you where or when something is happening, that is a time frame. Those are X value questions. Okay. That is a over this interval, this is being true. Okay. So these are both X values. -5 and -1 are both X values that we're using. All right. That's what we used. At -5, am I actually positive? Yeah, I'm actually positive. I'm going to use a bracket right there. At -1, am I actually positive? No. What am I at -1? 0. I'm 0. That's not positive. All right, so at -1, I'm not actually positive. So I'm going to use a parenthesis right there because it's not actually included in that positive interval. Okay, everything right up until -1, I'm positive, but at -1, I'm 0. That's not positive. I don't want to include it. Cool. There's my first one. Then at -1, I start to be negative. Tell me now when I stop being negative. There, -1 until 3. At -1, am I actually positive? No, I'm actually negative. No, I'm 0. So I'm going to throw a parenthesis on -1. At 3, I'm going to use a parenthesis because I'm not actually negative. I'm 0. Then we start going positive. From 3 until when am I going to be positive then? Infinity, because that line goes on forever. That arrow implies that. So from 3 until infinity. 3, I'm at 0. So I use a parenthesis. At infinity, technically I'm positive, but it's infinity, so I always use a parenthesis and I don't mess around with it. Makes sense on positive, negative. Next question is increasing. When we think of the word increasing, what are we thinking of? Going up, positive slope. Okay, so I always imagine this is a roller coaster ride. Okay, where you had a ball and you were being pushed along the graph. If I have this ball and I want to push it on the line, okay, if I got to push it up, it's increasing. If it's falling down, it's decreasing. Okay, sometimes your brain plays tricks on you, but if you go back to that simple, it's always pretty easy. Okay, starting here at -5, am I increasing or decreasing? Increasing. I'm gonna push that ball up from -5. Tell me stop when I stop increasing. Stop right there. -4. From -5 to -4, I got to push that ball up the hill. Okay. I hate this though, but depending on what textbook you have, they will change whether you should use brackets or parentheses here. Okay. Some people are like, well, at -4, you're not really doing either. So whatever. The good news is in calculus, we don't mess with that. When we talk increasing and decreasing in our calculus class on the AP exam, it's always brackets. So anytime you talk about increasing, decreasing, it's always going to be brackets there. So that makes life easier. -5 to -4, I'm increasing. Starting at -4, I begin to decrease. Tell me now when I stop decreasing. Right there. It would roll all the way downhill until we reach the X value of 2. Remember, this is an X value question. So from -4 until 2, I'm decreasing. Bracket on -4, bracket on 2, because I'm decreasing that whole time period. Starting at 2, I increase. From 2 until when am I going to increase? 2 until 4, I'm increasing. Then we start decreasing again from 4 until when am I decreasing? Just 5. Because what happens from 5 to infinity? Am I increasing or decreasing from 5 to infinity? I'm not doing either one. Okay, I'm constant. I'm 0. I'm flat. I've had 0 slope. So I'm not going to include that in terms of increasing and decreasing. Questions are there? What are the intercepts? Look at that graph. Show me with your fingers. How many intercepts does that graph have? I got some 2s. I got some 3s. Talk with your neighbor. Decide how many intercepts does that graph have. Intercepts. Where do we have an intercept here? What do you think, Lydia? X equals -1.
And then y equals -2.
Y equals -2. Wonderful. There are 3 intercepts. Is that a mean question? Yeah, probably is. Okay, normally they would ask you, what are the X-intercepts? What are the Y-intercepts? But don't forget, there are 2 types. Okay, we crossed an axis there, we crossed an axis there, we crossed an axis there. Just be aware. Okay, make sure we can identify those. All right, last one. Where are local maximums? And if you're watching this at home, I'm going to do something very visual, so you're not going to be able to watch it. A local maximum is where you increase and then decrease. That's what a local maximum is. It's considered local because you can't go any higher at that value. Okay? This little baby peak right here, 2 is as high as I can get. I can't go any higher than that. That's not the fault of the graph. It reached a maximum because it increased and then decreased. That's what makes something a maximum. So where are the local maximums? You got 2 of them here. At x is equal to -4 right here because I went up and then I went down. And then I have another local maximum right there at 4 because it went up and then went down. It's local because it's at that little place in time you reached the summit and then you went down from there. Make sense on what that's from, Sophia?
Why do you put x equals -4 and that's like the point, like -4?
Because it's a where question. It's a where is the local maximum. I don't care what the local maximum is. It's not a question of how tall is the mountain. Okay? It's like if I were to ask you where's the tallest mountain in the United States. If you told me 65,000 feet, that doesn't answer the question. Okay, the question is that it's in Washington. Okay, that's what makes it a where question. Where is it? It's in Washington. It's not, it's Washington at 6,500 feet. You could tell me that, but it's not what it's asking. Does that make sense? Where are the local minimums? Show me with your fingers. How many local minimums do you think this graph has? There's 1. What do you think has to be true in order for it to be a minimum? Decrease to increase. It's got to do both things. This is the only time period it does it. At 5, it's not considered a local minimum because it doesn't decrease and increase. It decreases and goes flat. So x equals 2 is the local minimum. Everybody understand those? Nothing groundbreaking, but again, it's just making sure we're all saying the same language. Okay, down below, I want you to do 1, 2, and 3 with your neighbor real quick. See what you can do, and we'll go over. We're trying to find f of 0 on this graph. What do you think f is 0 here, Kendall? What you got?
4.
F of 0 is 4. She's going to where the x value is 0. What's the y value? It's 4. Good. Aaron, what about f of 3 pi over 2? No, this Aaron, sorry.
0.
F of 3 pi over 2 is 0. Good. She's looking at this right here, her x value. That's her y value. And if we were to do f of 3 pi, Megan, what do you think on that one? -4. 3 pi, -4. Good. Just going with y values. It tells you the x value. Spit out the y value. That's pretty straightforward. What is the domain? So domain is the x values. We're working from the left to the right. So if we're looking at domain here, Kara, what do you think for your domain? Wonderful. 0 to 4 pi bracket. She's going from the left side over here. She's including that value, so that's why she used a bracket. And that graph continues to go all the way to here. And she used her x values here because we're talking domain. We're using x values 0 to 4 pi. Great. Now let's talk about range. If we're talking about range here, Eli, what do you think on range?
Bracket, -4, 4 bracket.
-4 to 4 bracket. Wonderful. Here's the bottom of my graph at -4. And it keeps going all the way to the top of the graph. That's the top of the graph. And he's looking at the y value of 4. -4 to 4. That's my range. Questions on the first 3? Try the next 4. List the intercepts. How many times? When is f of x greater than 0? When is it increasing? So list the intercepts. If I wanted to list the intercepts here, Abby, what do you say for intercepts? Hang on. X equals pi over 2, 3 pi over 2. Wonderful. What about any y-intercepts on that one? Yep. Y equals 4. Good. My paper just messes up. That's why I wrote in a weird spot. But good. Those are the 4 spots. She's talking about that point, that point, that point, that point, that point. Those are my x-intercepts. Show me with your fingers how many times does f of x equal -4? If it's f of x, that's y equals. Y equals is a horizontal line. So it's really asking you how many times did I cross that line right there? It's 2. There are 2 times when f of x equals -4. For what values of x is f of x greater than 0? Okay, greater than 0 here. And so I'm going to go through this quickly. I'm going to go from 0 to pi over 2. At 0, am I above the x-axis? Yeah, I'm actually positive, so I'm going to throw a bracket. At pi over 2, I'm not, because I'm going to put a parenthesis. Because here I'm actually positive my y value is 4. At pi over 2, I'm 0, so I don't want to include that. That one. And my next one goes from 3 pi over 2 in a parenthesis. That's a bracket. To 5 pi over 2. Again, this is positive, that is positive, and that is positive. So my last one that I need there is from 7 pi over 2 to 4 pi. Which one of those two needs a bracket? 4 pi, because at 4 pi I'm actually positive. At 7 pi over 2 I'm 0. Questions when f of x is greater than 0. Where is f of x increasing? Increasing means going up. And so when am I increasing? From there to there. From pi until 2 pi. I'm increasing. Anytime we talk about increasing, it's brackets. And then I'm also increasing from there to there, from 3 pi to 4 pi. Questions with properties of graphs? We're going to do the backside. We're going to go pretty quick here, though, because I'm running out of time. So on the backside, we're answering questions, but they gave us an equation instead of giving us a graph. Don't let this be hard. Is the point 1 comma 1/2 on this graph? How do I determine if the point 1 comma 1/2 is on that graph? Plug it in. I'm going to plug in 1. It says f of x is equal to, I'm going to plug in 1. When I plug in 1, I get 2/3. So is the point 1 comma 1/2 on that graph? No. 1 comma 2/3 is on that graph, but 1 comma 1/2 is not. Makes sense on the first one. If x equals 2, what is f of x? What's the point on the graph? How do I determine what f of x is going to be if x is 2? Plug it in. I want to know what f of x is? Cool. Well, I got an equation that's going to tell me what f of x is. I'm going to plug in 2 for x, and I get 3/4. That's what f of x is going to be. Or in other words, I get the ordered pair 2 comma 3/4. That's the point on the graph. If I want to know what the x value is, I'm going to plug it in. Number 3, asked you to find if f of x is 2, what is x? How am I going to determine if f of x is 2? What's x going to be? How am I going to determine that? Plug it in. F of x is right there. I'm going to plug in 2 for f of x. I'm going to plug 2 in for y. And so I get this problem right here. I got to solve it. I don't like that fraction. I got that x plus 2 on bottom, but I could fix that really quickly. I'm going to multiply both sides by x plus 2. Over here, it's going to cancel. On this side, I'm going to get 2x plus 4 equals x plus 1. Subtract an x. Subtract a 4. X is -3. The ordered pair is -3 comma 2. Last question. What are the x-intercepts of the graph of f, if any? What are the x-intercepts of the graph of f? How could I find out what the x-intercepts are going to be on that graph? Plug in 0 for, if I plug in 0 for y, yeah, good, 0 for y. So I could do that right there. 0 is equal to x plus 1 over x plus 2. All right, and you could solve it the same way. I'm going to make it even easier than that, because right now that looks a little bit complicated to solve. What I really want is I want the numerator to be 0. If the denominator is 0, it's undefined. And that's not really what I want at all. I want just the top to be 0. If they're both 0, that's a hole. I don't want that either. Okay? I want to know an x-intercept. So I'm going to go x plus 1 equals 0. So guess what the x-intercept is? -1. Okay? That's it. Pretty quick there, but that's the main idea.